This is the start of the unit called Scaling the Coordinate Plane. Proper graphs are important to convey information to many different fields, such as physics, chemistry, economics, agriculture, finance, and many others. It is important to use the right scales for the graphs. The labeling and widths of the boxes on the x and y axes enable a graph to be created so that the data points are properly plotted. A proper scaling of the coordinate plane will provide better data clarity, which will help ensure accurate conclusions and good decisions based on the data. Let's consider this scenario to illustrate that concept. A high school keeps track of teacher absences over a period of 10 school days. The data are here. Remember, the word data is plural. Create a scatter plot of the data to help the administration see a trend in the absences. So here we have days across the top and the number of absences in the second row. Data tables are excellent for organizing data, but sometimes it's hard to find a trend. Graphs are great for finding trends. So a couple key points of clarification. A school week is 5 days long, so day 1 will be Monday, day 2 is Tuesday, day 5 is Friday. You skip the weekend, so day 6 will be the next Monday. The administration wants to see if absences depend on the day of the week. There are 2 graphs represented here showing the same data. On the left graph, which is called teacher absences 1, and here we have on the right teacher absences 2. It's the same data, but take a moment and analyze the way these graphs are scaled or numbered. What do you notice about the similarities and differences of these 2 graphs? You may notice that the y-axis is labeled from 0 to 10 and on graph number 1, but in graph number 2, the y-axis is labeled from 0 to 100. The x-axes are the same. While this table doesn't quite tell the whole story, the teacher absent 1 graph, right here, clearly shows a trend that there are more absences on Mondays and Fridays. The teacher absent 2 graph over here is hard to read, so it is hard to find any trend. The teacher absent 1 graph is properly scaled and enables the administration to make policy decisions. It is now time to show how to properly scale the coordinate plane. In this plane, this right here, each box measures 1 unit and the maximum number in either direction is 10. So we look on the x-axis, the maximum number is 10, and when we go up the y-axis, the maximum number is 10. Also notice that the labels occur at each box. Here we have a second type of plane. In this coordinate plane, each box measures 1 unit and the maximum number is 20 in either direction. The labels occur every 5th box. So as I go along the x-axis, we see here we have a maximum number of 20, and moving up the y-axis, the maximum number is also 20. And when we count, they're labeled every 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on along the x-axis, and the same can be said along the y-axis. In this coordinate plane, each box along the x-axis measures 10 units, and each box along the y-axis measures 5 units. The maximum number on the x-axis is 200, and the maximum number on the y-axis is 100. The labels occur at every 5th box. This is the beginning of creating a proper graph for analysis. Let's consider this first example. Create a scatter plot in a coordinate plane to match the data that are given in the table below. In this example, the table shows that the temperature represents our x values and the number of people represent our y values. So if we look at this first scenario, we have our first temperature, the Celsius temperature is 19 degrees. The number of people using the pool will be 275. Moving down here, if that day has a temperature reading of 38 degrees Celsius, they can expect to have 525 people using the pool that day. Here's how we're going to set up our coordinate plane. Step number 1 is we want to count the boxes on each axis to help determine the scale. On the x-axis, we have 21 boxes across the bottom. In our table, the maximum temperature is 38 degrees Celsius. Let's use 40 degrees Celsius as the maximum value on the x-axis and use 2 degrees Celsius per box. Note, when rounding actual units, always round up. If you round down the actual units of measurement, then at least one of the data points will not appear on the graph. To compensate for that, always, when rounding actual units, always round up. 2 degrees Celsius per box works since we have up to 21 boxes and the range is from 0 degrees Celsius to 40 degrees Celsius. We only need 20 boxes to cover that range, as evidenced by this proportion right here. This means that each box has a measurement of 2 degrees Celsius. This is a practical solution right here, but it's important. Since there is not enough room to write units for each box, let's label every other box. And that's why you'll see along here we have 2, 4, 6, 8, 10, 12, and so on. But we labeled every other box, and that's why you see 4, 8, 12, 16 labeled on the x-axis. In order not to get the numbers confused with the dashes that are not being used, let's eliminate the extras. We still know that each box represents 2 degrees Celsius. We also need to add a label for the x-axis, which is the same label that is found at the top of the column in the table. Place this label beneath your units of measurement on the x-axis. The table was labeled temperature in degrees Celsius, and that's what we label here below the x-axis. And now it's time to turn our attention to the y-axis. On the y-axis, we also have 21 boxes, moving right up here. In our table, the maximum number of people using the swimming pool is 525. We set up this proportion, 525 people for 21 boxes, 25 people per box is what we'll end up with. That comes out to be a nice round number if we use the full scale. Since there is not enough room to write units for each box, let's label only the multiples of 100, making 4 boxes of 25. So here we have 25, 50, 75, 100, and that repeats right on up the y-axis. Next, remove the dashes that are not labeled to make the y-axis easier to see. Each box still represents 25 people. To make the x-axis even clearer, remove every other label and dash. Each box is still 2 degrees Celsius. The size of the boxes in the x-axis do not have to be the same size as the boxes on the y-axis. Label the y-axis and place the title on the graph. So on our table, the y-axis was the number of people. We placed that title on the y-axis. We also graphed the data according to the points. So the entire table was labeled the number of people using a swimming pool. That's the title of our graph. And we plot the points according to the data that was on the table. We are now going to turn our attention to our first practice problem. And here's the scenario. A jar containing 81 cookies was opened in a classroom. By the end of the day, after the students took them out and ate them, only 1 cookie was left. Every hour, the total number of cookies in the jar was recorded. A data table and blank coordinate plane are on the next slide. Here are the 4 areas of practice we're going to pursue. Letter A, we're going to answer the question, how many boxes are in the x and y axes on the coordinate plane? Letter B, what should be the width of each box on the x and y axis? Letter C, we're going to practice giving a label to the graph and to the x and y axis. And then letter D, we're going to practice creating a scatter plot of the data. So here we have the data. On the x-axis, we have time, and time goes from 0 to 7, as we see here. And then on the y-axis, we have the number of cookies, starting at 80, and then each hour it declines till finally at the end of the day, we're left with 1. Part A asked us to determine the number of boxes on the XY axis. So for the number of boxes, we count along the x-axis here, and we see that we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from here to here, we have 10 boxes. When we count on the y-axis, we also have 10. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coming on up. So the y-axis also has 10 boxes. For part B, we want to determine what should be the width of each box on the x and y axis. Now, when we talk about the width, we're not talking about the physical width of the box. We're talking about the range of values that that box represents. We're going to start with the y-axis first. The number of cookies ranges from 1 to 80. So each box should be at least, well, let's consider this. We have 80 cookies for 10 boxes, okay, 10 boxes on our graph. So we divide that out. 80 divided by 10 is 8 cookies per box. The number of cookies per box can be rounded up to 10 per box, as the units of 10 they're easier to graph than units of 8. So let's do that. Turning our attention to the x-axis, where we have time, the number of hours range from 0 to 7. So each box on the graph should be at least, well, let's take our 7 hours and divide it up by the 10 boxes on our graph. Comes out to 0.7 hours. Round that up to 1 hour per box to make a clearer graph. Part C, we are asked to label the graph and the XY axes. So, get my highlighter out here. The title of the table was Cookies in a Jar. That's going to be the title of our graph. For the x-axis, that's labeled time in hours. So that's what we have here, time in hours. The y-axis is going to be the number of cookies. So we label the y-axis number of cookies. I also want to take a moment and point out our labeling. Okay, so as we said on the x-axis, that's our time. We rounded each box up to 1. So you see we have 1 up to 10 on the x-axis. And for the cookies on the y-axis, we rounded each box up to 10. So each box represents 10 cookies. So that's why we have 10 down here, working way up counting by tens till we get to 100 at the top. And finally, we're going to consider part D, which is our ultimate goal, creating a scatter plot of the data. So at 0 hours, we started with 80 cookies in the jar, which you see right here. Next, 1 hour later, we're down to 68 cookies. So here's 1, and we're right about 68 is just below 70. And we continue doing that until we get to the 7th hour, where there's only 1 cookie left in the jar. Every other number labeled was removed for clarity to make this graph look cleaner and neater.